Electricity is one of the most common causes of fire in homes and workplaces. Explosions have also resulted from electrical sources. An average of 1 worker is electrocuted on the job every day. There are 4 main types of electrical injuries: electrocution, which is death due to electrical shock, burns, and falls. Each employer is responsible for providing a workplace environment that adheres to the OSHA requirements for electricity. Each employee is responsible for completing the training on how to safely deal with electricity and maintain a safe electrical working environment. Operating an electric switch is like turning on a water faucet. Behind the faucet or switch, there must be a source of water or electricity with something to transport it, and with a force to make it flow. In the case of water, the source is a reservoir or pumping station. The transportation is through pipes, and the force to make it flow is provided by a pump. For electricity, the source is the power generating station. Current travels through wires, and the force to make it flow is provided by a generator. Dry skin has a fairly high resistance to electrical current, but when moist, resistance drops radically, making it a ready conductor. Use extra caution when working with electricity when water is present in the environment or on the skin. Pure water is a poor conductor, but small amounts of impurities, such as salt and acid, which are both contained in sweat, make it a ready conductor. An electrical shock is received when current passes through the body. The severity of the shock depends on the path of the current flowing through the body, the amount of current, and the length of time the body is in the circuit. Low voltage does not mean low hazard. A small current that passes through the heart and lungs is capable of causing severe injury or electrocution. Low voltages can be extremely dangerous because, all other factors being equal, the degree of injury increases the longer the body is in contact with the circuit. Currents greater than 75 milliamperes can cause rapid, ineffective heartbeat and will cause death in a few minutes unless a defibrillator is used. 75 milliamperes is not much current. A small power drill uses 30 times as much. Electric shock normally occurs when an individual is in contact with the ground and is also in contact with either both wires of an electric circuit, one wire of an energized circuit and the ground, or a metallic part that has become energized by contact with an energized conductor. The metal parts of electric tools and machines may become energized if there is a break in the insulation of the tool or machine wiring. Electrical burns are the most common shock-related, non-fatal injury. Electrical burns typically occur on the hands and occur when you touch electrical wiring or equipment that is improperly used or maintained. An electrical burn is a very serious injury that needs immediate attention. Electric shock can also cause indirect or secondary injuries. Workers in elevated locations who experience a shock can fall, resulting in serious injury or death. A hazard exists when a conductor is too small to safely carry the current. For example, a hazard is present when using a portable tool with an extension cord that has a wire too small for the tool. The tool will draw more current than the cord can handle, causing overheating and a possible fire without tripping the circuit breaker. The circuit breaker could be the right size for the circuit, but not for the smaller wire extension cord. If too many devices are plugged into a circuit, the current will heat the wires to a very high temperature, which may cause a fire. If the wire insulation melts, arcing may occur and cause a fire in the area where the overload exists, even inside a wall. An overcurrent device is a device which limits the maximum amount of current that can flow in a circuit. The basic idea of an overcurrent device is to make a weak link in the circuit. In the case of a fuse, the fuse is destroyed before another part of the system is destroyed. In the case of a circuit breaker, a set of contacts opens the circuit. Unlike a fuse, a circuit breaker can be reused by reclosing the contacts. Fuses and circuit breakers are designed to protect equipment and facilities, and, in so doing, they also provide considerable protection against shock in most situations. However, the only electrical protective device whose sole purpose is to protect people is the ground fault circuit interrupter. The ground fault circuit interrupter is a device that continually matches the amount of current going to an electrical device against the amount of current returning from the device along the electrical path. Whenever the amount of current going differs from the amount returning by approximately 5 milliamperes, the device interrupts the electrical power within as little as 1/40th of a second, protecting you from a dangerous shock. These devices are able to detect the loss of current resulting from leakage through a person who is beginning to be shocked. If this situation occurs, the device switches off the current in the circuit. Grounding is a physical connection to the earth, which is at 0 volts. Current flows through a conductor if there is a difference in voltage, electrical force. If metal parts of an electrical wiring system are at 0 volts relative to ground, no current will flow if our body completes the circuit between these parts and ground. Most people don't realize that overhead power lines are usually not insulated. Workers who are working around power lines need special training and personal protective equipment to work safely. Do not use metal ladders around power lines. Minimum clearance distances for employees working in the vicinity of overhead power lines are given in OSHA requirement documents. Electrical accidents appear to be caused by a combination of 3 factors: unsafe equipment and/or installation, workplaces made unsafe by the environment, and unsafe work practices. The following are some examples of electrical safety hazards and violations. The path to ground from circuits, equipment, and enclosures must be permanent and continuous. The violation shown here is an extension cord with a missing grounding prong. Handheld electrical tools pose a potential danger because they make continuous contact with the hand. To protect you from shock, burns, and electrocution, tools must have a 3-wire cord with ground and be plugged into a grounded receptacle, or be double insulated, or be powered by a low-voltage isolation transformer. An employer must guard live parts of electric equipment operating at 50 volts or more against accidental contact. They may do this by using approved cabinets or enclosures, or partitions making the live electrical parts accessible only to qualified persons. They may also elevate the electrical equipment 8 feet or more above the floor or working surface. Mark entrances to guarded locations with warning signs. The employer must enclose or guard electric equipment in locations where it would be exposed to physical damage. The violation shown here is physical damage to conduit. Junction boxes, pull boxes, and fittings must have approved covers. Unused openings in cabinets, boxes, and fittings must be closed. This photo shows violations of these 2 requirements. Flexible cords can be damaged by aging, door or window edges, staples or fastenings, abrasion from adjacent materials, and/or working activities in the area. Improper use of flexible cords can cause shocks, burns, or fire. Flexible cords can be used for fixture wiring, portable lamps, tools, or appliances, or stationary equipment that can be easily interchanged. Flexible cords cannot be used as a substitute for fixed wiring. Flexible cords cannot run through walls, ceilings, floors, doors, or windows, or be concealed behind or attached to building surfaces. Some clues that electrical hazards exist are tripped circuit breakers or blown fuses, warm tools, wires, cords, connections, or junction boxes, a ground fault circuit interrupter shutting off a circuit, or the presence of worn or frayed insulation around a wire or connection. Employers must train employees working with electric equipment in safe work practices, including de-energizing electric equipment before inspecting or making repairs, using electric tools that are in good repair, using good judgment when working near energized lines, and using appropriate protective equipment. In summary, some of the biggest hazards of electrical injuries are inadequate wiring, exposed electrical parts, wires with bad insulation, ungrounded electrical systems and tools, overloaded circuits, damaged power tools and equipment, using the wrong personal protective equipment and tools, and overhead power lines. All hazards are made worse in wet conditions. You can prevent electrical injuries by proper grounding of electrical wires, using ground fault circuit interrupters, using fuses and circuit breakers, guarding live parts, proper use of flexible cords, and training. This has been a production of Federal Safety Solutions. For more information, please visit fssamerica.com.